In this example, I would like to solve a trigonometric equation involving a double angle identity. I would like to solve on the interval 0 to 2 pi of the cosine of 2 theta plus the cosine of theta is equal to 0. The technique that I'm going to show you is not one that has to be used every single time, but it does employ a pretty good strategy. And the strategy is, if you have two different angles within your problem, try to express it in terms of the same angle. So goal, express in terms of the same angle. Now with that in mind, we have three different identities for the cosine of 2 theta. One of them is the cosine squared of theta minus the sine squared of theta. And let's make use of that one. Unfortunately, that puts us in the awkward state of now we have the same angle, but we don't have the same trigonometric function all the way throughout. So I am going to employ a Pythagorean identity, which technically I could have done from the beginning, and that'll allow me to arrive at one of our other double angle identities for the cosine. Now if I distribute the negative sign and then combine like terms, I'll have a cosine squared of theta minus negative cosine squared theta. That'll be 2 cosine squared theta. We'll still have a plus cosine of theta, and we'll also have a minus 1. This is starting to look a little bit more familiar. So we have the same angle for all of, the same angle and the same trigonometric function for all of these. So that's looking pretty good. Now with that in mind, we are going to factor this. It is quadratic form. So what you can do is think of how would I factor 2x squared plus x minus 1 equals 0. Now I'm thinking to myself that in order for the first term to be 2 times the cosine squared of theta, I will need a 2 cosine theta and a cosine of theta. To get a 1, I'll need a 1 and a 1. Then to make sure that the inner and outer terms wind up giving me a positive cosine of theta, I'll need the 2 to be positive, I'll need the 1 to be negative. That gets us here. Now, setting each of these equal to 0 using the zero factor property, that tells me that 2 times the cosine of theta minus 1 is 0, or the cosine of theta plus 1 is 0. Solving each of these resulting equations for the cosine of theta, I get that the cosine of theta is equal to 1/2, or the cosine of theta is equal to negative 1. So the three angles that I would be looking for on the unit circle would be the angles where the cosine is equal to 1/2, so a quadrant 1 and a quadrant 4 angle, or the cosine is equal to negative 1. You'll notice that there's a nice little symmetry to these three angles. The three angles that I'd be looking for, the ones that produce the 1/2 would be pi over 3, 5 pi over 3, and the one that produces negative 1 is pi. So final answer for this one, if we're going to go solution set notation and put them all in numerical order, that'll be pi over 3, pi, and 5 pi over 3.